even care what this function looks like, right? It's some mess, and I'm going to try to find its integral, its area under the curve from 2 to 10, by breaking it up into this case 4 rectangles. 1, 2, 3, 4. Each rectangle is going to have a little length that we call delta x. And delta x is always b minus a over n. So 10 minus 2 over 4. So 8 over 4, which is 2. Which makes sense, because if we were to keep adding 2, yay, it works, right? So then, if we want to do left-hand rectangles, my first rectangle is going to be in this region here. And I want to start my rectangles with the height on the left side of this region. So therefore, I'm going to start at the 2. And so for left-hand rectangles, you always start with A. So your left-hand rectangles, your first height is going to be f of 2. And then your next height, you can see it from there, but if the numbers were to get nasty, you just keep adding delta x over. So f of 4 plus f of 6 plus f of 8 until you get all the heights of all your rectangles. F of 4, f of 6, f of 8. Notice you don't go all the way to 10 because that's not the height of the last rectangle. So you're going to add until you have those 4 heights. And the area of a rectangle is base times height. So since the bases for all of them are the same, that delta x, you can factor it out of all of those. And so now to evaluate, delta x we said was 2, and to get f of 2 you just plug it into there. So that's the square root of 2 cubed plus 1 is 9, plus the square root of 64 plus 1 is 65, plus the square root of whatever the heck 6 cubed plus 1 is, plus the square root of whatever the heck 8 cubed plus 1 is. I'm going to leave it like that. So there's L of 4. The rest of them have the same idea. Now if I want the right-hand endpoints, I'm going to draw that in green. When I make my first rectangle, I'm not starting at the left side of the rectangle, I'm starting with my height on the right. So I'm not going to start at A, I'm going to start delta x over. So I'm going to start at 4. So and once you have your starting spot, you're good to go. So I'm going to start at f of 4, and what I mean by you're good to go is you just keep adding delta x. Once you get to the place you start, just keep adding delta x. Delta x was 2. So now it's f of 6 plus f of 8 plus f of 10, right? That'll give my next f of 6, f of 8, f of 10. Those are all the heights. And multiply that by my delta x, which was 2. And then just, that's the setup. Just plug in to find those function values. So f of 4 is the square root of 4 cubed plus 1 is 65. 6 is whatever 6 cubed plus 1 is, square root of 8 cubed plus 1, square root of 10 cubed plus 1, whatever the heck that is. Last one we're going to do, we're going to find the midpoints. Now the midpoint, you don't start at the left or the right, you start in the middle. So you start at, not at A, not at A plus a full delta x over, but A plus a half a delta x. So I'm going to start at the 2 plus a half of delta x is 3. And you can see it from the picture, but when these things get nasty, you don't have to draw a picture if you just sort of can think of what's going on. So I'm going to start at f of 3 for my first height is f of 3. And then once you've got your starting spot, just keep adding delta x until you get the right number of heights for your rectangle. We wanted 4 heights, and we got that. Delta x was 2 because the width of these are 2, so that's the area, the base times the height, base times height, base times height, base times height. All of your rectangles added up. All you got to do is plug in these numbers. So 3 cubed plus 1 is 28. Cubed root of 5 cubed plus 1 plus cubed root of 7 cubed, square root of 7 cubed plus 1, I can talk, 9 cubed plus 1, there it is. Not so bad. If you were to punch these all in on your calculator, you would get these crazy numbers, right? That should all be roughly the same, that should all approximate to that integral. The reason we want to use these approximations is because that integral, that's kind of a nasty one. I'm not quite sure how to do that. A U sub won't work right away. You'd have to really play with that. And so we have these approximations to make it easier for ourselves. There you go.